So, hello. I'm going to talk about microservices in production in Newsweaver. I'm going to try and give you an overview of what microservices are, some of the costs that you need to pay in order to run them successfully in production, and some of the benefits we're noticing. So I'll start with a brief introduction. I'm Damien Daly. I'm a tech leader in analytics product in Newsweaver. We've got a tech blog there with a link. It's quite active, and we dive deeper into a lot of topics that I'm only going to be able to skim across today. So, Newsweaver, who are we? We're an internal communications company, so we enable companies to communicate with their employees through emails, and then we provide measurements on these emails. About a year and a half ago, we started a new module or product, which is an analytics product, and as part of that, we started a microservices architecture with the idea that over time, we'd migrate the existing application to the microservices architecture. It's a SaaS-based product. We've got 2 live environments, one serving the US and one serving the rest of the world. Slightly low for you. So these are only some of the companies that are our customers. We can't put them all up there because we can't say all of them. It's not the NSA or anything. So our companies can range in size from having 5,000 employees up to having 250,000 employees. So microservices. Who here, show of hands, who's familiar with microservices and understands somewhat what they are? I'm expecting a lot of hands over here. Okay, so I'll try and give a brief explanation of what microservices are. It's quite an in-depth topic, so I'll just try and give a rough outline of what they are. So microservices are small autonomous services that work together. They're small, focused on doing one thing well. So if you try and isolate all the things that change together, you put them into a service. All the things that change somewhere else, you put those into a service as well. This is a quote from Adrian Krokov from Netflix. He was working in Netflix around 2008 when they migrated to microservices architecture, or they started migrating to it, even though the term wasn't coined then. And he's talking about bounded contexts here. That's from Eric Evans' book, Domain-Driven Design. It's a bit, I won't get into it all, but I'll just give a quick, it's probably the easiest way to explain it is to give an example of it. So a bounded context, inside Newsweaver, one of our bounded contexts is the reporting context. So anything around reporting lives in this bounded context. That bounded context is composed of a number of microservices. Another bounded context that we might have would be the employee bounded context. In the employee bounded context, all the logic, business logic that goes with employees goes, and we interact with each other through interfaces. So I'll give you a couple of key characteristics of microservices as well. So one of the key ones is each microservice type has its own database. So this is to try to discourage the coupling that you can get through databases. So you might have your code decoupled, but what you might often find is that the database request is reaching over into a different part of the application's code, and so if you try to change it here, you're affecting part of the application over here. Another key characteristic of microservices is they have separate deployment cycles. So they shouldn't be coupled. You shouldn't have to deploy one microservice when you're deploying another microservice, even within bounded context. Now there is some coupling between them, and there is to get a full feature out, it's possible that you will have to deploy 2 microservices, but you should be able to deploy them independently. So we come to the silver bullet. There's a lot of hype about microservices at the moment. Most software blogs, software sites have articles on microservices. They're not, strangely enough, a silver bullet. There's a lot of costs associated with them, and if you have issues with the composition of your software in a monolith, and you move to microservices architecture, and you follow the same composition, all you're going to end up doing is distributing the mess that you have, and you're actually after making it worse because now you've got distributed mess, which is much more difficult to deal with. This is a werewolf from Michael Jackson's Thriller, and it does tie in. So I'll get there. So silver bullets are for killing werewolves. monoliths are not a werewolf. They don't need to be killed. There's different requirements for different systems. Monoliths, there's plenty of successful monoliths. We've all worked on monoliths that are successful. There's loads of successful monoliths for big companies that we all know about, like Etsy. It's just another approach to building software. So after the werewolf, our approach. So when we started looking at ways to re-architect the application and build our analytics product, this was a new area for us. We didn't know how you went about it. We didn't know how you composed, how you broke context down into different microservices. We had already been looking at bounded context in Newsweaver as part of our existing platform, but we didn't understand any of this. So one of the core tenets that we've had is the concept of lean, both for our infrastructure and for our features. So we start with the smallest valuable thing, and we build that, and we delay decision making until the last possible moment, because at the last possible moment is when you have the most information. Another thing that we do for each of our services, we always deploy 2 instances of the service. This is to stop us getting to the situation where we need to scale a particular microservice, and we go to add a second one and we realize they're clashing. So it's like Noah's Ark, we always take 2. Another one that was kind of difficult for us to get our head around, and we still have a difficulty with it, is I'm sure we're all familiar with the dry, don't repeat yourself. It's not the worst thing in the world. There's a cost value balance there that needs to be met. So when you've got microservices, your whole thing is you want to decouple, and you only want to speak through interfaces. And the temptation is, I've got a service here and it's doing this thing, which is kind of similar to this thing I'm doing over here in this service. Why don't I make a library? You've got a coupling right there. As soon as you create that library, you start building that. So you start building that library, and you start adding extra functionality into it, and all of a sudden you've got a dependency between them. And it's not always the worst thing to copy and paste code from one service to another. So another part of the lean approach is that we're continuously, everything we deploy, we're looking to improve. We're looking for continuous improvement with what we deploy, our infrastructure and our processes. If you saw our architecture diagram for our first shot at this a year ago, it doesn't look like what we have now. We started with this weird kind of layered services type architecture, which just wasn't making sense, and it's quite a bit different now. Which leads me on to my next point, because it's quite short development cycles and there's short feedback loops. Don't get too attached to your code is something that we all have to live by, because we might do something small and it doesn't make sense, and so then the approach we've taken is wrong. So we throw it away quite a bit and move on. But all these are quite small services, so the cost is reduced. Another big part of our approach to development is, because we've got a lot of services even within a context, they communicate through their APIs. I forgot to mention our services APIs. It's REST based, and we communicate in JSON or communicate with JSON. We define these interfaces through CDCs or consumer driven contracts. So a consumer of an interface will specify what it's expecting in terms of REST endpoints and what it's expecting in the payload. It'll give this to the producer of this information, and that's tested against during the testing phase of the build. So we know when we're after breaking a contract. So when we're in our services, as long as we're adhering to our contracts, we can be sure that the system is still going to work. We found collaboration very good with those, because they're the starting point of a story. If you've got multiple services that are going to be interacting, and you've got 2 developers working in them, they can come together and define even though it's the consumer defining the pact, the producer developer and the consumer developer will come together, and they'll start with a pact. This is what I'm expecting. This is what. So, cost of running in production. Unfortunately, this is not free. There's a cost. It's a distributed system, and it's not just about the code. So it's not as simple as taking an application, making it into loads of small little applications. There's quite a bit of automation required, because all of a sudden you're not dealing with our release. So on our existing application, our release cycle is every 4 weeks. That's not so bad doing that once every 4 weeks. There's manual steps. We can deal with it. Our release cycle on our new architecture is you release it when you're ready. So when a story is ready, it's released, or when you get a bug in and you fix it, it's released. So there's quite frequent releases. So we require a certain level of automation. So we automate our builds, we automate our testing, we automate our deployments, and we automate our service discovery. So that last point on the service discovery, if you've got quite a lot of services coming up, they need to speak to other services, and we can't be going in coding IP addresses, part configuration, or updating environment variables. So we have service discovery running that Pierre did a talk on a month or so ago, 2 months ago, and we have a service discovery running. Basically what this is a service will come online. It will register with Central Registry. I'm here. This is what I do, and it will also ask this Central Registry for all the services it depends on to carry out whatever actions it needs to. The automation for the testing, so we automate all our testing, including our acceptance tests, including our acceptance tests. The other big thing that we need is to automate is our monitoring. So if you've got 1 or 2 systems, or however many systems, that's quite a small number. It's monitoring can be more hands-on. Once you move to quite a lot of services, it's too hard for us to deploy all these services and to be going over checking this box over here and then back over here to check this box or around our system. So we've automated a lot of our monitoring. So as part of our deployment pipeline, we deploy dashboards to our monitoring system. So we create a service, and we've got a default set of metrics that we expect to be exposed. And normally we'll also have some business metrics that are defined as part of the user story that will expose as well. That dashboard definition is deployed during our deployment pipeline. So benefits, the good part. So one of the main benefits are aimed at being agile and being quick to respond to change. That's the overall big ticket. That's what it's about. But some other benefits that we experience is localized failures. So the failure isn't the benefit, it's the fact that when we do fail, it can be localized. So a few weeks ago we had a failure on one of our screens. So we've got a screen, it's simplified, we've got like 2 graphs and we've got a table showing stuff. And our stuff that was populating, our information that was populating the table was starting to take too long to retrieve from the database because it was growing in a way that we weren't expecting it to. So that request was timing out after it came in. But the failure we had was the table didn't show, the widget showed, the whole screen showed, it was fine. We were able to identify that was the problem, put in a quick fix, send it through our build pipeline, automatic testings or staging environment right through to our live environment, and then go back and approach the problem properly, because it was actually coming from somewhere else. But that whole from start to finish was 3 hours. So it was quite short, able to respond quite quickly. Another benefit we were getting from it is zero, which was kind of implied in that story, was zero downtime deployments. So I know you can do zero downtime deployments in other architectures and with other approaches, but our zero downtime deployments was almost the byproduct of having the microservices architecture. There wasn't much work for us to do to enable it. We just had services. Some of them go down, we can switch them back in. Most of the screen is still going to be working. We're definitely noticing a quicker turnaround on features and bugs. It's easier to go into an isolated part of the system and know it's not touching all these places all around, and conceptually just understand what's going on there. As long as you're adhering to your API and packs, you're safe in working within that. Another big benefit that we're experiencing is we're going through quite a bit of growth as a company at the moment, and we're hiring a lot of developers. If anyone's interested, quick plug. We're hiring quite a lot of developers, so we're starting to onboard quite a few developers. It's much easier to bring someone in and show them one service, start them there. They start understanding what's going on in a small part of the system, and slowly spread it out. I think of it like the GTA. I don't know if anyone played GTA, but when you start GTA, there's a map and it's all cloudy, and you can only see the parts of the map that you've been to, and the rest of the map slowly dissipates as you go around the system. Our system's like GTA. Yeah. So. Another benefit as well is again to do with scaling as a company. We're getting more teams, and the more things you have, the harder it is to operate. But in this type of an architecture, you've got your bounded context, which is your collection of services as one particular part of the team. There's Conway's law, and it goes something along the lines of your software will mimic your organization. And the example that's used, if you have 3 people building a compiler, your compiler will have 3 parts. So our teams that we're slowly rolling out and starting to form, we form them around a bounded context, and that team owns that bounded context, one or more bounded context. They're the subject experts on that. They know it best. So it's nice for us to give a team to have ownership of a particular context, a particular part of the code, and it forms a natural API barrier for that bounded context. So I'll run through some of the text we use quite quickly. This can only be an overview because I don't have enough time. So our services are written using the Dropwizard Java framework. It's for developing RESTful web services. It's quite nice. It brings a lot of different libraries together and packages them up in Dropwizard. If anyone's familiar with Spring Boot, it's pretty much it's very, very, very similar. Next is another hype machine of the moment, Docker. We really like Docker. We use it quite extensively. Docker is our unit of deployment. So when we build, Dropwizard creates a jar, but the artifact of the build is a Docker image. That image is immutable, and it works its way through the different environments and the build pipeline. And once that's created, we don't go back into that image. It's done. Kubernetes is Google technology, and we use it for orchestration. And that's a fancy way of saying that it takes our Docker images, and we tell it at a basic level, we want 2 instances of this particular service to be running, and it makes sure 2 images of that particular service is running across our cluster. It's quite nice. Yeah. So our monitoring is central to what we do. So we use Grafana for our dashboards. Grafana is very nice. It can take multiple different data sources and combine them in one graph. We really like Grafana, and also we use Prometheus. Prometheus goes around and collects the metrics from the different services. Prometheus is a SoundCloud technology, and it's very nice as well. We've got some blog posts up about these on our tech blog, and we will be doing more. For our logs, we used Elk-Stack, so we send our logs to Logstash. We view them through Kibana, and Kibana use Elasticsearch to query Logstash. Oh, bit ahead. Okay, so now I'm going to try and give you.
What are you using for registration and discovery of services?
Okay, so we use SmartStack at the most. Okay, so we're using SmartStack at the moment. SmartStack was from Airbnb. There's actually a talk online from Dev.io, and we've got stuff on our blog about it as well. But when I was saying at the start, we start lean and we tackle one problem at a time. We weren't sure what we were going to use for orchestration, but we needed service discovery, so we started using SmartStack. Kubernetes started coming to the fore for us as an orchestration tool. We had been looking at CoreOS and Fleet and etc., but Kubernetes started making more sense. Why I'm saying this is Kubernetes has service discovery mechanism inbuilt in it. We will eventually move over to that but right now it's not a priority. SmartStack's very simple, and the service discovery is kind of decoupled from what we're doing, so we don't mind it. But if we're starting now, we would go Kubernetes and its own service discovery. So the context. This is our reports context. This is a very simplified view of our reports context. There's auxiliary services I've taken out, and there's no authentication or authorization or anything, or any of those concerns in it. Each of these services, roughly 500 lines of code in or around. They're not big, they're quite small. So this is our analytics context. The piece you're not seeing here is we also have a Spark Cassandra cluster working on all that stuff coming in and producing the reports that we're going to serve up. That's why these can be quite so small. What the interesting thing here is so we've got two metric services that serves up metrics that we're interested for the front end. One, we're after we serve up employee level metrics, and the other we serve up content metrics. There's loads of other ways you could have split this. This is how we decided to split it. And then we have a front API service, which is for our web application front API, and that handles requests for that and routes them to the correct places. Since we started using this, we're getting validation. We're going to conferences and we're reading articles, and slowly but surely we're getting validation of the approaches we're taking. And this is a recent one that we're after getting. So this kind of approach to having an API for a particular view feeding into the context. You could also imagine an external API feeding into this context as well, not through this front API. We've started seeing some articles starting to be released around this, and apparently it's called the BFF pattern. So it's a back end for your front end. SoundCloud talk about it, and so does Sam Newman. Okay, so this is what a typical service for us looks like. So as I mentioned previously, we create a drop wizard jar, and that is packaged in a Docker image as part of our build process. When we're deploying, these are deployed not inside a replication controller. Replication controller is a Kubernetes concept, and it's metadata about your services that you're deploying. When I was saying earlier, Kubernetes handles making sure that two instances are running across your cluster. This replication controller descriptor tells Kubernetes there should be two of these running. There's other stuff around there as well, but that's the main part of it. As part of everything that we, as part of all our services, we obviously have our business logic that we expose, but we also require a health endpoint and a metrics endpoint. I've already touched on these. So the health endpoint is Boolean, are you healthy or not, yes or no, and the metrics is various monitoring metrics. We've got default ones that we must expose, and then we've got additional ones that make sense for a particular service. We also have ones coming in from product management and UX that they're interested in for a given service. So, what happens when you get a bug? Panic. Point fingers. Definitely recommend it. No. We create so we use Stash we use all the Atlassian products. So we use Stash, we use Bamboo and Jira. Stash and Bamboo are relevant here. So we use Git. So when we get a bug, we create a bug fix branch in Git. The developer fixes the bug, pushes that up to our Stash Git repo. Bamboo automatically notices when there's a new bug fix branch or a feature branch after being created, and it creates a build. That build builds it, creates the image at the end of it, but first it runs through the automated tests, part of which are the contracts that the CDC contracts that it has to adhere to. Once that is done, the developer goes and creates a pull request, and we need at least 2 approvals for it to go past this stage. Once we've got the approvals, it's deployed to staging via Kubernetes. Acceptance tests are automatically run. Then it's deployed to live again via Kubernetes, and we run synthetic tests on live. While the synthetic tests are running on live, no other services can be deployed. So there's one when you start developing these services, it's what constitutes a live system, what constitutes a staging system. There's question marks around that. So our live, if you take the state of our live to be n, our staging is only ever at most n plus 1, where the n the plus 1 is one newer release or one newer version of at least one service. Yeah. So, quick recap. Start small. Definitely for us, we made mistakes at the start, and we didn't know everything we wanted to do at the start. But by starting small, we limited the risk. There's many benefits. Pay the costs in tandem with the application development. So we very much took a step forward on a feature, then we took a step forward on the monitoring or the automation. We tried to do it in tandem. And again, a lot of the learnings we had from this can be applied to other architectures. It's not tied to microservices. So, questions? Yep.
I would like to know a little bit more about your test strategy. What kind of test do you have in that architecture? I mean,
okay,
you
so
mentioned the contract test that you are using, and I've seen also the acceptance test at the end of the pipeline.
yeah. So the question is, what sort of tests do we use in this architecture?
Yeah.
So we've got our unit tests to start with. Our integration tests are our CDCs. So if we're saying that we're adhering to all the contracts for people that are depending on us and they're all passing, we're happy enough that all our services will work together. We've got our acceptance. We've also got unit tests on our UI, so our Angular tests. On top of that, then we've got our acceptance tests once we go to staging, and we've also got our synthetic tests. So our synthetic test will be: can you do the main things in the application? Can you log in? Can you see stuff? Can you create a campaign? That they run continuously on live. And it's kind of an alarming mechanism. If the user can't do the main things they want to do, there's something wrong. We don't know where something's wrong, but there's something wrong. Yep. Anybody else?
So is there any issue with latency between different services? Do you keep all your services in one data center?
Yes, they are all in one data center. We haven't got any latency issues yet. That sounds like we're going to have them, but we're not experiencing any. Yep.
Sorry, I'm starting to learn about microservices and stuff, but what if you have, with CDCs, consumer-driven contracts, one producer, one supplier, whatever you call that, has to cater for multiple consumers.
Yeah.
Is it possible for those contracts to conflict or something? And isn't the fact that you have to cater for multiple consumers a form of coupling in itself?
Okay, you're catering for a number of consumers, but you should be satisfying them in one way. I suppose your service should be satisfying them in one way. So we do have multiple packs drawn up for multiple consumers, but typically they'll work off the same data set. So if you have multiple things using one thing, they should be using, if you're constructing your service correctly, they should be using it for the one thing, which is the things that tend to change together. So the employment metrics, you have other services depending on the employment metrics, but you're still only doing one thing, you're still only giving employment metrics. Yes?
I'm just curious about using drop wizard versus Spring Boot. What were
when we started, Spring Boot wasn't very mature, as I seem to recall. And one of the things that, which subsequently you can do this, but one of the things as well that drew us to Drop Wizard was the Coda metrics or the Yammer metrics. It had a library of metrics that it exposed automatically, and you could annotate your endpoints various ways, and it was quite nice. As well, one of the other benefits of microservices, you don't have to have all your services using the same text. So it wasn't a massive decision for us. It was like, let's try this and we can go with this. We still might have, you could have, so if another team in another context might well use Spring Boot to write the services, as long as they fulfill the monitoring contracts, and they can hook up to the service discovery. It's not really an issue.
you create a repo, Git repo per per context?
S-
Or
yeah,
how do you handle that?
some of the stuff isn't quite nice for that. So we create so in Stash you got the concept of a project, and within the project you can have multiple repos. So that's quite simple. We have one Stash project for a context, and we have a repo per service for that context. But in stuff like Jira, then there's not really a nice mapping between multiple services, multiple contexts. So you're kind of stuck in, do I have a Jira project per context, or do you have one project for multiple contexts and create different dashboards? Still something we're still trying to figure out what the best approach is for. Okay.